reminder to start recording it. And that way, for those that registered for the session, you'll receive the recorded event here. I'll also send you some links to previous recordings and some training events and training materials so you can reference those if you have additional questions or needs to get more familiar with SciFinder-n. So without any further ado, I'm going to hand this over to Gary. Gary, I'm going to go ahead and pass the presenter ball to you.
Great.
And as you guys have questions during the session, I encourage you to submit those to the chat. I'll try to answer the ones I can, and for those that I cannot directly address, I will try to get Gary's attention to address those questions during the presentation. Thanks so much, Gary. I'm going to go ahead and stop my video so I'm not distracting.
All right. Thanks, Lauren. Appreciate the introduction here. And thanks to everyone for giving us a few moments of their day. Hopefully there will be a lot of tangible benefits that you'll pull out of this, new capabilities, new optimized workflows, things like that. And I leave my video up for just a second so you can associate a face with the name. And sorry, got a little thing in my viewer window there, but I will also turn off my video just for bandwidth reasons. We'll be doing some searching here, and some of those will get a little slower if I do not turn off the video. So I'll do that now, and then I will also start sharing my screen. There we go. This is once you log in to SciFinder-n, this is the home page that you're going to come to. Just very briefly, for those of you who haven't had the opportunity yet, to compare this to the SciFinder Classic version, you'll see the ability to do substance reaction and reference searching, just as you always have been able to do. And bringing to the home page, we now have a supplier search. So if you're just want to find out more about a compound, are there commercially available suppliers out there? Do they have pricing? Maybe I can initiate an order. That is now on the home page. That was a big ask for a lot of our customers. They want to save time and not have to go through several pages. So this is addressing that. And then there's an all search. So if I'm in a new topic area, I can enter a search query in the search bar here, hit return. The search will then bring back the top couple of answers from each of these different search fields, if applicable. And you can kind of gauge, yeah, I'm on the right track, or no, I need to maybe refine this before I launch a full-scale search. New to the home page as well in SciFinder-n are the last 4 searches I've run. Just so you know, SciFinder-n was created with a completely new data model, a new search engine, such that, as Lauren alluded to, you can search without limits. Here's the last 4 searches. If I want to see all of my searches, I can go to the history tab here, and this will now bring back all my searches. I can scan through them, 22 a page. I've got 439 pages, so that will take me a while. And that's why we put in some additional filters over here. So if I know I'm going after a reference search or reaction search, I can refine down quickly to that. Also, if I knew the day of the search, maybe we're talking online saying, hey, we were online talking, last Wednesday. I was talking about that retrosynthesis. Here, let me pull it up. I'll go back to that day, scan through and say, yeah, remember we were talking about the retrosynthesis here. Let me open it up. So as you can see, that really helps you get to things quickly. If I can't remember the exact day, I can put in a range of dates. All these things helping you to get to what you need as quickly as possible. A couple of other things, hopefully everyone's aware of. At the bottom of every search page, you have some help options. If I click on the help hyperlink here, this will take me to the help page. And no matter what type of searching that I'm doing, if I need some help, this is where I can find it. If I'm doing substance searching, reaction searching, reference searching, if I'm trying to learn more about the retrosynthesis planner, I can pull all those things up here. Something else I'd like to point out on this page, if I click on About SciFinder-n, you can come back to SciFinder-n webinars. So obviously COVID has had a large impact on all of us. One of the things in my position is I usually do a lot of traveling. Since I'm not doing a lot of traveling, myself and my peers took that extra save time and we produced some webinars on different topics. So if I click on this, I can get to this page. And so if I want to learn a little bit more about substance searching or reaction searching or reference searching or using the retrosynthesis tool, all these things are now hyperlinked here. If I want to see what's up and coming, I can do that here. So you can see we've got one coming up on the 14th, talking about searching in pharmaceutical realm, and then another one coming up on inorganic chemistry. So keep an eye on those. Get to this page, click on this. Registration is very easy. Once again, good ways to make use of time, especially if you're having to be out of the lab or at home. Watching these webinars can be very beneficial. All right. And I guess one thing I did not show was the contact us page. If I'm having a problem and I want to throw it into an email, this is where I can do that. Someone should get back to you within 24 hours. If you've got a big demonstration tomorrow and a certain capability isn't working or what have you, we do have a customer care center that you can call where degreed scientists are manning the phone lines. If that person can't answer their question, they'll forward you to someone who can. So also 8 a.m. to 6 p.m. Eastern time. So if you have, the term I always use is mission critical problem, this is the place you can go. But as always, you can always contact Lauren as well. But this is just something, like I say, if you've got a operational issue that you need some help with, you can get it very quickly. All right, so let's launch in now. And in this presentation here, I'm actually going to start in the area of reaction searching. And to expedite things a little bit here, I'm going to pull up a reaction search that I did previously. So I'm clicking on my history button that pulls up all the searches I've done. And now I said it was a reaction search that I want to pull back. And as I scan down, this is the one that I prepared that I actually want to use. So I'm going to go ahead and I'm going to pull it up so you can see what the reaction I'm searching is. So in this situation, I'm looking at the reaction of aryl aldehyde boronic acids with alkynes to give chiral indenols. Hopefully, most of you are familiar with the use of the CAS draw tool, somewhat similar to ChemDraw, but with many differences. I was just on the home page, and if you want to find out what all these features are over here, that's something that we provide in the help page for you. So give you all the training that you need there. I'll go through a couple of things here. First of all, I can use variable groups. R groups, I can make up to 20 of them. You can see I've incorporated 2 here. And when I put my cursor on it, it's going to actually tell me what functional groups I have in there. So I selected to put proton or any halogen or methoxy or an ethoxy group here. And my second one, as I fly over it, I put any alkyl group, any cycloalkyl group, proton or methoxy group. So, and I can make up these R groups by clicking on R group, selecting, I'm going to make an R3 here, and now I can add to the R group functionality from any of these 3 areas. First of all, by clicking on this, I get the periodic table come back. So if I want to say nitrogen, oxygen, sulfur, that type of thing, I can choose all those I want. I can also put in any variable that I want. The variables that we've created are any halogen, any metal. You can read on through here. And these can also be associated as R groups. And lastly, shortcuts. We did this just to kind of make life a little easier. Who wants to draw out a big phosphate group or something like that? So we've created some shortcuts here. We hope to add to them. But once again, a lot of things that you'll see that I'm presenting will be ways to save time. All right. So that's how I can put function groups into my R groups. And then I just wanted to show a couple of different capabilities here. One is a variable attachment point tool. So here I'll take my R group, I'll plop it down here, and then I click on the variable attachment point tool. Now all I need to do is click on here, and then I need then drag to the positions of the ring in which I want to see the function, at which I want to see if the functionality exists in the literature. So I click here and drag to this position, click here and drag to this position, which is what I've done. So what this is basically showing is you've got an R group. These R groups are attached to this ring, aligned to the middle, and then the dotted lines go out to the points in the ring which you elected to attach that R1 to. So, I can bring in another R group and attach it to different positions or what have you. So this is just a good way, rather than you having to do multiple searches, you can kind of incorporate everything to R groups, put them at variable positions, and then do kind of one big macro search, which is what I'm going to do here. The second thing that I've done is I'm looking at reactants going to a product. There will be more than one way to get to a product of this ilk, but if I'm really interested in this reaction, I can then use something called the mark bonds tool. And what I'm telling it here is saying in making of this product, these are the bonds that are created. So this will help take away a lot of the noise, a lot of the answers that I might get that aren't exactly what I'm looking for. So these are just a couple ways that we help refine your search down and make it exactly what you're looking for. So having put this together, I'm now going to upload this to the search bar, and I'm going to run the search. So this is now going to look for this reaction in the literature. I'm going to pull back all the answers and put them into a couple of different bins. The first bin is as drawn. So what this basically is telling me, these are exact answers for what I was looking for in my query. You remember over here, I said proton was one of the variable groups I put in here, so that's an answer. And here, I was looking for alkyl groups was one of the functional groups in the R group here. So that's a direct answer, and getting this product. Now, when we search the literature, we found 3 examples of this exact transformation. And so what we'll do is we'll put them together and put them into a scheme. So these 3 reactions are in scheme 1. And Lauren kind of pointed out, this is a pseudo new, well, this is new to SciFinder-n, is the ability to do sorting by schemes. If you remember in SciFinder Classic, you could do it by document. You may say, well, Gary, I like doing it by document. Okay, you have that ability. The default is by scheme, but if you want to do it by document, you can do it by document. What are the benefits of doing it by scheme? So in this case, I've got 3 transformations found in the literature. It puts them side by side so I can compare the conditions, catalysts, reaction times, temperatures, all that. And it will also sort them highest yielding to lowest yielding. So what do we got here? We got one reaction that used a cobalt catalyst, one that used a rhodium catalyst, and one that used a palladium catalyst. Also, something that we associate here is if there's experimental protocol information associated with it, you'll see a hyperlink here. And if I click on this, I can reveal an example of methods now synthesis. Hopefully most of you are familiar with this, but what this is a value added thing that our human curators have put together to help everyone with the kind of reading of a procedure in the literature. A lot of times, if you've read the literature for long enough, you've come across protocols that look like long run-on sentences, kind of difficult to interpret. What are they doing first? What are they doing second? Well, in the creation of this, we take a lot of the guesswork out of that. So we'll take all the products, reactants, catalysts, and solvents that are there. We'll parse them out into their own line. We'll give them a hyperlink. So if you want to investigate more about a reactant or a catalyst, I can do that. I can find out more about it, or I can look for suppliers, maybe get some pricing, maybe launch into an actual purchase. And then that procedure, since all our human curators are degreed scientists in a given field, they can read that and say, what they did first was they did this, and then they did this, and so on and so forth. So it's a nice recipe style format, amounts, times, temperatures, all incorporated, also workup conditions. If there is characterization data provided, we also put that in as a part of the methods now synthesis. So once you're done and you've isolated your product, you can go run some spectroscopy and say, yeah, this looks great. It's all matching up really well. Or I've got some differences here. I might not have isolated the right spot. So this is something that's very nice to hand off maybe to a newer person in the lab while they're getting their feet wet and figuring out where all the chemicals and stuff are. Nice procedure here that's make it a lot easier on them in that realm. Once again, help them get up to speed if they're new to the lab. All right, so just showing you what the methods now synthesis looks like. If you were in the SciFinder Classic, you either had to purchase a license to it, or if you didn't do that, we gave you access to 5 of protocols a year. In SciFinder-n now you have unlimited use of them, so that's great. You can also download them, that type of thing. So take advantage of that. All right. Additional filters over here. If I want to use a certain solvent, You know, if I'm only interested in using 1,4-dioxane, I can click this and it gets rid of everything else. So I'm not spending time looking at procedures that aren't going to fit what I need to do. Also, if I want to use a certain reagent or a certain catalyst, I can do that. I can click on the reaction notes. If I want to just look at stereoselective transformations, I can refine by that here. Um, so once again, all these things are hopefully going to help you get down to what you need for your specific situation, and reduce the amount of time that you're flipping through protocols, figuring out whether or not it's actually going to work in my given situation. All right, so these were the as drawn. In reaction sorting, we often will have a substructure and similarity. The reason that there's no similarity here is that we do have a variable group. So if you do incorporate R groups, then we can't use the Tanimoto similarity algorithm to do similarity sorting. But if you have a reaction that doesn't have variable groups in them, you'll also get similarity hits as well. So the second bend we have is substructure. So in drawing out these structures, there are certain ones where I put in all the explicit hydrogens or something like that. So if all my valences aren't filled out, when it's looking for substructures, it will look for substitutions off of these sites as well. And you can see what is part of my query is highlighted in blue. What's not is not highlighted in blue. Um, so so that's what makes it a substructure. Now, I didn't point out one of the filters over here because I wanted to show its value here in the substructure field. So let's say I'm looking to use this transformation in a synthetic scheme that I'm currently working on. But in my specific situation, I've got a remote functional group that I'm a little worried about it being surviving the conditions here. Because as I look at some of these conditions, I'm seeing acid, I'm seeing metals, I'm seeing heating. So I may have some reservations. So what I can do then is I can go over here and click view all, and it will show me all the different non-participating function groups. And what that means is a function group that's present in a starter material and still present in a product. In my situation, my non-participating functional group is an aldehyde. So by clicking that and hit apply, it will bring back, in this case, just that one reaction. And so here we see it. Here's my aldehyde on my arrow ring here, and also in the product. Very relieved to see that this went in a 93% yield, and even also happy to see that I've got experimental protocols associated with this. So rather than me, if without this functionality, I probably would have had to pull back 5 or 6 sets of conditions, go into the lab, shoot a bunch of singletons, see which one looks best, do all the analysis and stuff like that. That could take me a half day or a day. Well, with the ability to filter down here and get down just this one set of conditions, now I can run in and try a reaction, see if it works. If so, great, I'm ready to roll. But since I'm only doing this one reaction, I can probably do something else at the same time. So the capability here will hopefully make you more efficient, maybe ability to do a little more parallel processing when you're not doing stuff that is destined to probably not be the best conditions for you anyhow. All right. So that was the reaction tool, and I wanted to transition into another type of reaction tool, and that's our retrosynthesis tool. And in this specific situation, let's say there's a compound that I've seen in the literature, and I can I can do a substance search for that. I could bring that in as a name of a compound or a CS registry number, or I could draw it out if I want to. In this case, I'm going to go ahead and I've got a CS registry number for it. So I'm just going to copy and paste that in. And I'm going to remove my reaction from previous, and I'm going to go ahead and I'm going to search that compound. So here's the compound that I brought back. I kind of like this compound because it had some stereo centers in it. Kind of a little curious, how was this made, what have you. But this is a compound that's currently in clinical trials as a treatment for breast cancer. So like I said, I might want to know exactly how this is made. Now, in SciFinder Classic, and even obviously now here in SciFinder, if I want to look at reactions, I can look at transformations that give me this, but I'm interested in kind of, starting material all the way to products. How, if I want to start to engage in the synthesis of this compound, what starting material should I use? What's the best pathway? Well, that's what the retrosynthesis tool can help you with. So if I click on the structure, it's going to give me this flyout window, and I have another of pieces of information I can look at. Or in this case, I can create a retrosynthesis tool. As Lauren pointed out, we have the ability in SciFinder-n to have multiple tabs. If I right click on this and open this link in the new tab, I can preserve what I was doing before and have the retrosynthesis being generated in another window. So once I'm done looking at this retrosynthesis, I can go back to what I was searching. So you can see it came back pretty quickly. It found an experimental scheme that was we pieced together using transformations from the literature. And how do I know that? So there will be two different types of transformations that will be in your retrosyntheses. Those that have a purple solid line mean that these were transformations we actually found published in the literature. So we found the reaction of C plus the reaction of D to give the reaction of B. If I go up here into my steps tab, we actually found two pieces of evidence. So this was published in two different places. And you have the ability to, if you want, actually open up that evidence and see, where was this found? Maybe I want to get this article and study this transformation a little bit. So one was in a patent, one came from a JMed Chem article. So, if I right to that, I could open up, look at the full text. And then we have the ability to use Patent Pack here. So if you have not had the opportunity to do that yet, if I click on Patent Pack, I will always see the PDF. But for certain patents, we've done additional work and created something called a viewer and a PDF plus. So if I click the viewer, that will bring me to this page here. And so here's the compound that we were trying to make. And so what our human curators have done is they've read this patent, seen that the key compounds were in there. They've pulled those compounds out, assigned them a structure, and then associated that with a CS registry number. And then they've also put a link into each place they found that compound in this patent. So I can click on the first link, and here we go. This is the synthesis of the compound. So this is great. This, might have been the reason I was looking in here anyhow. So I can get right to that information. 152-page patent, and in a couple of seconds, I've gotten to write what I would be looking for without scanning, flipping, what have you. So that could be big time savings. I see multiple page numbers here, so I can click on the second one and see, oh, they've got an alternate preparation. All right, that's good to know. I've got a couple different ways I can do this. Lastly, here's the compound that was used in an additional step where they oxidized here to give this tetrasubstitute nitrogen. So the material that we were interested in was used as a start material in that reaction. So that's great. Like I said, I can find everything that I want to find out about this compound, this patent, just by doing those few clicks. And something I wanted to point out is the purpose I was coming into this patent was to look for this compound. However, while here, I'm like, I didn't know that they also created the ester. I can click on this structure, and this will give me another flyout. So if I want to, investigate this a little further, I can go look at reactions or ways to synthesize it. I could do a retrosynthesis of this if I wanted to. Look at, got some suppliers, all that type of stuff. Now I can, go off and do this in another tab. So you have a lot of ability, to see something on the fly, put it into another tab, do a little research, and then come back to exactly where you were. So this is the viewer capability, and I can use this while I'm sitting at my computer. Now, if we had a lot of customers saying, we love this, and is there any way you can put that information in something that's downloadable? So that's what we did when we created the PDF Plus. So all the information you see over here in that scrollable bar, that's now going to be attached to the end of the patent. So all I need to do now is go to the end of the patent, and here you can see, the table. So once again, here's our compound of interest. I can see that, it's on page a number of different pages. and we've put a marker in there because there will be multiple compounds on most pages, so it might be easy to get a little like, especially if it's a very long compound name like this is what's being used in the text. Um, these marks can be very helpful. So I just need to go up to page 76. And here we go. So there's my mark 1. So I know this is the compound that I'm in here for. Once again, it makes it very easy, very straightforward. So like I said, you can create these documents. You can save them to your desktop. You can email coworkers. Very useful tools. Because it's got all the information you need at the end of the document to get to the right portion of the patent that you need. So that is the PDF Plus capability. All right, now showing you reaction results here, and let's get back to the retrosynthesis plan. So what else we got here? So here's the compound that we're trying to make, and I know this probably looks very small on your screen, so I'll kind of blow it up a little bit. And we're trying to disconnect this compound, simplify it, till we get back to reasonably priced, commercially available starting materials. And what does that mean exactly? So that means $1,000 per mole or less. So that's what we're attempting to do here. So and here are the starting materials that we got back to. When we pull these transformations out of literature, if there's a yield associated with them, we'll put them into the scheme. And we also have something called a ChemCats database. So a lot of chemical suppliers will submit their catalog to our ChemCats database. So when you're looking for a specific compound, what have you, and you, especially in the scheme here, if you see this supplier's hyperlink here, if I click on that, this will fly me now into the ChemCats database. And I've got 112 suppliers for this compound. They'll create a document that looks like this, so I can see the names, purities, most of them have pricing information and availability. So I've got a lot of different suppliers to choose from. So I can go over here and use some of these filters. No surprise, my boss wants this done yesterday, so I'd like something that can ship, within a week. And I feel better if it was maintained in stock, so I don't get some surprise a week along. Oh, we checked our supply, we don't have that anymore. So I've got plenty of options here, so I'm going to click that as well. And since I'm in the U.S., I would really rather have a U.S. address. I point out for those of you that may be collaborating with other labs, and maybe these labs are in other countries, also nice to know that if they're doing some of the work and this is one of the transformations they wanted to do, that China would be able to access this starting material without having to go outside its country borders. So no worries about customs, things like that. Anyway, so once I go through and make all my selections, I can even then download these into an Excel spreadsheet, which would make things a lot easier if I'm going to go do the ordering, or if I'm going to hand it off to a purchasing function, make their life a lot easier, and that it's all fairly straightforward, because we'll have all the information that's needed, emails, pricing, links to supplier websites, things like that. So that's the ChemCats database that backs up our database here. So if I can find pricing and I've got yields, now not only can we give you the scheme, but we can tell you we're going to estimate that you can make this material in 32% yield. It's going to cost you about $425 in starting materials. So that can be very useful. So as you put together different schemes, you can figure out, well, what's the best way, what's the most reasonably priced approach, things like that. We talked about the evidence already. We do, if we find alternative ways to make a compound, we'll associate that as well. So if I click on alternative steps here, it'll show you the one that was chosen and another way that we found to make that compound. So if there's some reason that you have a reservation about this, you do have another option here. And let me, new capability that's come online here is if there is a transformation in your scheme that involves stereochemistry. Now this can be, as you see up here, the formation of a double bond. And here we see clearly a trans double bond being formed. If the author has documented the stereoselectivity, E versus Z or what have you, then this icon will appear. You can drill in and look at that information. So once again, if I go in here, I click on evidence, this is telling me that this transformation, they characterize the absolute stereochemistry. So as shown, this is the absolute stereochemistry of the product that they got. And so that can be very useful information. Obviously, chirality, very important thing. You don't want the wrong enantiomer, the wrong diastereomer, especially if you're doing any type of work on trying to characterize the activity of a compound. And this is basically telling you if please consult this article if you want to make sure you're getting this specific diastereomer. All right. So I showed you that this was an experimental scheme that came back, and you'll see this predicted tab over here and this little spinning window. So what this is doing is, as I showed you here, that I don't have alternatives for a couple of my steps. So this is kind of going into the literature and looking for other ways of doing a transformation. So these transformations are exactly taking B, converting it to A, found in the literature. But as you look at what was the transformation that was actually done here, in this case, it was the hydrolysis of an ester. It may find other compounds where an ester was hydrolyzed and the structure was fairly similar, but not exactly the same. So that's what it's trying to go out and find. So you will have some other alternatives, maybe some additional conditions that you can try. So sometimes this takes minutes to an hour or something to run because it's having to go out and do a lot of similarity searching. I'm going to go into my history here, and I'm going to pull out when I've run this one previously. And let's see. Okay. Sorry about that. I don't know why it dumped me onto the wrong date. Okay. So in this case, this is bringing back one time when I ran it and the predicted results finish. So when they finish, if you're sitting at your computer, it will send you an email. If I open up a scheme, after I've run it, and I wanted to see the predicted answers as well, I can click to turn those on. And so now look what we got here. So went into a little more depth, and I didn't point out explicitly, but we were up in the $20,000 range now. Now that I've gone back an additional step, done like another level of disconnections, I've now dropped the price a great deal because some of these were much more expensive than some of these star materials. So this drops the price of my overall scheme. And something else that's different here is you'll notice this green dotted line. So this is a situation where it didn't find this exact combination of K plus L to give H, but it found similar ones. So it's suggesting sets of conditions that you could use to accomplish this transformation. So if I want to actually look at those, I could open up the evidence, and I could use all the filters over here to kind of go through the different possibilities and see which ones are best suited to my situation. And it's given me over 800 ones to look at, so I can, as I said, take advantage of these filters and get down to the conditions, the catalysts, the solvents that I want to specifically use very quickly without having to rifle through everything. So, all right. So that's the retrosynthesis scheme, and I've shown you how to use that to make a known compound. So the question always comes up, can we use this to do unknown compounds? And let me just very quickly go through an example where that is the case. I'm going to bring up, a substance. Olaparib. This is a compound approved for use against B-cell cancers. And let's say that we were interested in looking at this compound. Maybe we have a crystal structure and we figured out if we could put a nitrogen right here, this would give us a good contact, hopefully increase the activity of the compound, by giving us a stronger binding, that type of thing. So what I can do now is I can go up to substances and say, is this compound known? And the answer is not as drawn, not as a substructure. There are ones out that are nothing with the nitrogen in that place. Great. Is it covered by another patent? So I can do one way I can look at that is I can look at, we have a patent Marcouche database where all the patent Marcouche structures and patents are reside. We're going to search and see if this is covered by any of them. So I can go ahead and do this search, not as drawn, not as a substructure. Great. All right. So, this is a novel compound. Maybe it behooves us to go after it. So now I can go into reactions and I can create a retrosynthesis plan. So it's going to try to find an experimental way to do it, but it's not known in the literature. So it's not going to find one, but that's where the predictive algorithm will kick in. So let me quickly go into the back to the day, planet, and here it is. And so this will look a lot similar to the other schemes that we saw, but once again, it's not known, so that last step is going to have the green dotted lines. But as I go in and I look at the evidence associated with that, so I'm trying to connect an aryl aldehyde here to a benzyl halide. So I look at my evidence here. I want to hopefully see something that's fairly close to that. So I think that, yeah, we could go after this. So almost the exact same situation, actually, from the synthesis of just doesn't have the nitrogen out here. So this reaction is pretty well characterized, 92% yield, great. So I can feel maybe moderately comfortable that would be a good approach to that. So anyway, let me know if there are any questions on that, but I do want to try to move on and hit a couple other things here before the end of the webinar. So my next stop is going to be reference searching. So I'm going to click reference. I'm actually going to do an advanced search. So in my situation, I'm looking for publications in the University of Akron. And go ahead and search that. And it's going to pull back over 11,000 references associated with the University of Akron. And in my situation, I'm looking for a specific author here. And I'm going to go ahead and click. You'll notice the sorting by most cited to least cited author. That's been an option for a long period of time. We've introduced a couple of new options now with, if you know what the last name starts with, I can go right to that. Most of the time, I just like going straight to the search here, and I'm looking for publications. The name I have is Stephen Chang, so I'm going to see what we've got here. If you looked over here, he was actually the most cited author in this search. But something I like to point out too is sometimes publications, they might have publications under slightly different derivatives of their name. So his most cited name is the Z period D period associated with the Stephen Chang. But you see, he potentially has quite a few other publications here that maybe, depending on who the editor was, maybe they forgot the periods, what have you, didn't put a space between the two. and if I'm trying to be comprehensive about finding these authors' names, then I might want to go ahead and do the search and make sure I'm pulling absolutely everything back. So the last thing I want to do is like pull back just these and saying, you know what, I didn't find that article that I'm pretty sure he published, and that was because in that specific case, maybe you know, they didn't have the space and they had the ZD without space there. So anyway, just wanted to bring that to your attention in the event that you do a search and you're kind of flummoxed as to why you didn't find something. All right. So in this situation, I'm going to go ahead and just pull these back, and then I want to show a specific capability here. And the searches are done by relevance, and we'll talk about. But in this situation, I want to find the most cited articles by this author to highlight something called the citation map. There may be a specific article here that I'm pretty interested in. I'd like to know more about, you know, who this author cited, maybe who has cited this author himself. So if I click on citation map, it's going to, and this actually has quite a few citations, so maybe I should pick them. There we go. So and even this is something that has changed within the last week, right? So over here, if I want to see the top articles that were cited in this article. So these are all the references Dr. Chang gave for this article on crystallization temperature dependent crystal orientations. And so I can kind of page through these one at a time and see, you know, who were some of the other authors here. Notice the information I'm getting, not only the title and the top authors and the journal, but it's also saying how many times was that article cited. So that can be very interesting because, you know, if I'm interested in this topic, I might want to see what are the seminal publications out there. And this one had over 2,900 citations. So perhaps I want to go look at that. And the coloring here is put in to kind of tell you that this is highly cited. And as I go down, this gets lighter and lighter. You can see that there are fewer and fewer citations, and there are more to look at if I want to. And then on this side, this is showing what authors have cited this article. So this is a publication in 2000. Maybe I want to see what has been published moving forward, you know, since then. So you know, I can kind of page through here. There's a 2007. You know, maybe I want to look into that because that's 7 years newer and see, you know, what's happened to the technology in that period of time. We also have the ability over here, if you don't like paging over it like that, I can go over here and these are the cited by. I can put these into a scrollable window if you find that's a little easier. And then same thing with these over here. That's also in a scrollable window. Filter by. This will help, you know, if I just want to find things on melting point, or I'm looking at a specific other author with respect to this, I can do that. And just want to point out that if I find that this article is really important to me, what I can do is I can actually set an alert on it. And so what will happen then is every time someone cites this article, I'll get an email with the one or more references that have cited this. So it's a good way for me to keep track of who's publishing in a given topic area by setting an alert like that. All right. All right. So in the couple minutes I have left here, let me just do one really quick reference search. And in this search, I'm going to look at calcium channel modulators for the treatment of epilepsy. So I'm going to go ahead and search that. I said that I'd kind of point out, you know, what's novel here about the SciFinder-n and the fact that it's searching and bring you back the answers sorted by relevance. So it's looking for all the topics in here present in the title, in the abstract, and in the concepts. And what the concepts are, that's when our human curators read an article and they say, what were the top topics of this article? And so you can see they've associated a number of them here. And you can see that I'm also hitting, my search query is hitting on terms in here. So a certain score is associated to that, along with the keywords that the author has in here. I'm also hitting on those. So we'll add up all the points for my terms appearing in the different places here, and the top scoring article will be the first article that I see. So even in a situation where you've got 45,000 hits here, in all likelihood, the things in the first page here are probably going to be pretty relevant to me. So that's a very nice thing. And then just quickly wanted to talk about optimizing your search query here. In a very high level, this is doing a search that's kind of going calcium or channel or modulators or treatment or epilepsy. It recognizes prepositions and phrases like that. So there is some smarts to it, and you can see that it will also be looking for synonyms for given terms here. So you can see with epilepsy, it's also highlighting like seizure. So it's saying that's a relevant synonym for this search query. But if I want to optimize this a bit, I can pull in some of the Boolean operators, and Lauren pointed out those are and, or, and not. So I've got a lot of hits here. So I'm going to actually refine this down a bit. Treatment is a kind of word that might be introducing a lot of noise to my search, because treatment can be talking about diabetes, can be talking about epilepsy, can be talking about cancer. I want to get terms that are going to bring back things very specific to what I'm looking for. So I'm going to actually replace that by an and. And then I've also seen modulators or blockers. Maybe I should be incorporating blockers as well. Make sure I don't want to miss anything. If they're calling them modulators or blockers, let me put it in that term as well. And since these are synonyms, I'm going to put these in parentheses. And then I'm going to put in one more and here, because I want calcium channel and modulators or blockers and epilepsy. Last thing I would like to do with this is to point out you can also use wildcards. So if you're worried that you want to pull in all the different conjugations of a given word, so my example here is like for modulators. If I put in an asterisk here, it will find modulate, modulates, modulator, modulation, modulating, all those different things. And I'm going to do the same thing with my blockers. I'll put in a wildcard there. All right, so I've optimized this query. I had almost 46,000 to start with. After doing this, I've now got all the way down to a little longer than I thought I would. But these are all different things that will just help refine it down. So I went all the way down to 3,900, and you can see now it's highlighting the blockers and things like that. So this it does some filtering on its own. But assuming that you don't know how to optimize your search query. So I usually turn this off and make sure I'm not missing anything, because I've used all the appropriate querying tools here. You can see it almost doubled the number of references I had, so that's good. And then lastly, we have a number of different abilities to refine the search down here. If I just want to see the patents, I can just click on the patents. If I want to look just at biological studies associated with the search term, I can do that. If I want to go in and refine down, just show me like the last 5 years, that's something else that I can do and make things much more relevant to what I'm trying to find. You also have the ability here to refine by author, which you showed before. Organization, this is a good competitive intelligence tool. Who else is working in this area? The University of California. We should keep an eye on Berkeley there. They've got a lot of publications in this area. Concepts, I showed you where the concepts were. So if I wanted to refine this down a bit, I could say, you know what, I'm actually specifically looking for voltage gated calcium channels. So I can search there, and you can see, wow, there's quite a bunch of different channel that we associate here. If you work in this area, you probably know which ones to specifically pick out, but that's something else you can use to refine on your query. All right, so sorry, I kind of ran out of time there a little bit at the end, but hope you kind of get a flavor here of how to refine your reference queries and how to use the filters over here. So let me turn it back over to Lauren.
Thanks, Gary. Really appreciate you going through all those basics. I'm going to share my screen again to give people an idea of what they can do if they need to have specialized training. So as Gary mentioned, he went over some of the more advanced features in SciFinder-n, namely retrosynthesis and some of the search strategies that you can do. If your lab group is involved in something that is a little bit more esoteric or specialized, and you want to arrange a training or want to learn how to use SciFinder-n for your specific applications, please feel free to reach out to me at lider@cas.org and check out some of our training materials on our website here at this URL. I wish everybody good luck in their research, stay safe, and best wishes for 2021. Thank you so much, Gary. Take care, guys.
Sure. Take care.